Thank you very much, Terry. And let me just expand a little bit on the biography that you very graciously provided. So, 27 years ago, working with my pal Tony Parisi, we invented the first three-dimensional interface to the World Wide Web. The World Wide Web was not really in common use in early 1994 when we did this work, but it was already clear from my own work in virtual reality that we were going to be able to use 3D as a medium. The same way we use text and web pages, we would be able to use 3D as a medium. And so we very quickly created a demonstration of something that we called Labyrinth. And if you go to markpesce.com, you can actually have an experience of Labyrinth because we found the original files. They still run on Windows machines. So you can take a look at what the original 3D web was like back 25, 26 years ago if you want to. And then we were invited by Tim Berners-Lee, who's the father of the web, to bring our work in and to make it a core standard for the World Wide Web. Now, it has since been superseded. You wouldn't expect a technology that's 25 years old to really still be running today. There's a modern technology called WebGL, but the WebGL is the direct descendant of VRML. So whenever you see 3D inside of a web browser, that's kind of the grandchild that I see out running in the world. Now, I have been working in virtual and augmented reality for 30 years now. Started working in that in 1991. And as you can imagine, things that were very clumsy back 30 years ago are now very easy to do today. What I want to talk about is the next steps that we're taking, which are going to be into the world that we would fully call augmented reality. And I want to talk about what that means. But I want to start with a story, and this story you'll see is explained in detail in the reading of the introduction of my book, Augmented Reality, which I know that you've been assigned. And this story has to do with a little game that maybe you've played called Pokemon Go. Of course, it's hugely popular, developed by Niantic and Nintendo working together. And the both of them together created this amazing title that basically situates you in a landscape that's filled with all sorts of wonderful machines. So, here's the story. Australia was actually used to beta test Pokemon Go because Niantic wanted to make sure that they had all of the infrastructure that they needed to make the game a success. And so it was released to the app stores, the Google and Apple app stores in Australia, about 72 hours before it was released anywhere in the world. And that was basically on a Friday in Australia. And I remember that Friday because I had a friend visiting me on her first trip to Australia. And we were running around Sydney just seeing the sights. But we kept on seeing all these little clusters of young people, sort of people 18, 19, 20, whether we were on a train or walking around in public, and they were all staring at their smartphones. And we realized that they were all really playing Pokemon Go. They were really enjoying playing Pokemon Go. And it was becoming a very social activity. Well, that social activity had an unintended side effect, and that's really where I want to start my talk today, because this is Peg Patterson Park. If you have been to Rhodes, and it's right on the train line about, 20 minutes outside of Central Station, if you go to Rhodes, you get off and you walk about 2 minutes, you'll come to Peg Patterson Park. Now, Peg Patterson Park is an utterly unremarkable park. It is just a little postage stamp strip surrounded by housing blocks on every side. It's a place where you could walk the dog, where you can put the kids on the jungle gym to let them burn off some energy, particularly important, I would think, right now during lockdown. It is an unremarkable piece of urban landscape. But Niantic, the company that had invented Pokemon Go, had done a lot of work in an earlier game called Ingress, which maybe some of you had played, which was basically the first augmented reality game. Ingress was a kind of capture the flag game where there's two teams working globally to capture particular landmarks. One of those landmarks was in Peg Patterson Park. And so when Niantic created Pokemon Go, they basically took the entire database of the world they'd used for Ingress and they brought it over. And so that meant that Peg Patterson Park had Pokestops and Pokegyms inside of it from day one. And as kids fanned out across Sydney, they found out that Peg Patterson Park actually had these features in it. And when they got to Peg Patterson Park and found out that it had those features in it, they messaged their friends. And their friends jumped on the train and came over to Peg Patterson Park and had a play. And then one of those friends spent $1 and dropped a Pokemon lair to attract some nice Pokemon. And then there was some excellent Pokemon there. And then those friends would message other friends saying, hey, if you're playing the game, come over to Peg Patterson Park. There's people people dropping Pokemon layers. There's all these rare Pokemon here. You can challenge your Pokemon in the Poke Gym, and so on and so forth. And basically, that started a cascade, a kind of avalanche of social behaviors. People messaged, and then people messaged, and then people messaged. And so by Tuesday night, July the 16th, 2016, this is 11 p.m. at night at Peg-Patterson Park. This is video footage that's shot by someone who is living above Peg-Patterson Park in one of those housing units, trying to get some sleep because it's 11 p.m. on a Tuesday night. And what you have here now is about 1,000 people who are arriving on train or arriving in taxis or arriving in Ubers, and they're all coming not to have a riot, not to drink and carouse, but basically all to play Pokemon Go. And the thing is, of course, the more people who arrive, the more people are dropping Pokemon lures, the more attractive Pokemon are being dropped here. And so what you get is this acceleration effect. And the police had to come along in about another half an hour's time and break up the quote-unquote riot in Rhodes, which is the title of the introduction of the book. Now, this wasn't actually a riot. No one was hurt. Everyone was very well behaved. But what it shows you is that when we change space, when we as human beings inscribe data into space, and this is what Niantic had done more or less innocently when they created the Pokemon Go game. When we change space, we change our behavior in it. Changing space changes us. All right. Here's a recent tweet. This was tweeted last week when I was actually preparing this lecture. Someone showing you some statistics still 5 years later about Pokemon Go. All right, and you know, if you drop a Pokestop near a restaurant or other public space, it increases traffic into that restaurant. We know that some very, very clever cafe and restaurant owners would in fact drop Pokestops by their spaces to increase foot traffic. We know that people would walk tens of thousands of steps per day when they were playing Pokemon. And according to this tweet, I have not verified this, it led to 145,000 car accidents. But I will tell you a story. Not long after Pokemon Go had been released, I was taking an Uber in from Melbourne Airport to downtown Melbourne because I was going to be giving a talk somewhere. And the Uber driver was going off about the fact that he was on the CityLink the day before, and someone in the car, his passenger, demanded that they stop on the CityLink during peak hour because he just saw a rare Pokemon. And of course, the Uber driver did refuse, and the passenger got quite upset about this, but I think the passenger had no real idea that he was putting himself in danger because he was so involved in playing the game. So, although I can't verify the data in that tweet, there is anecdotal evidence that I saw to support this assertion. So what we have here now is an augmented reality game that has created such potency in the way that we're interacting with space. It really is changing our behavior. In some ways, it's allowing us to be very avoidant of our own safety in space. All right, let's talk about what augmented reality actually is, because there's going to be, particularly going forward, quite a bit of confusion around this, and I really want to strip away some of the technological artifice around augmented reality to talk about what it is in its essence. What it is in its essence? Well, the roots of it lie in a paper from 1965 written by Ivan Sutherland. If you don't know who Ivan Sutherland is, you need to go check out his biography, go look at Wikipedia, maybe go take a look at some of the work he's done. All interactive computing. And this is not an overstatement. All interactive computing has its roots in Ivan Sutherland's work. In 1963, he created the first truly interactive computer program, one called Sketchpad. Anytime you touch your finger to a smartphone screen and that smartphone does something, it is replicating what Ivan Sutherland invented in 1963 with Sketchpad. So all interactive activities on a computer basically descend from his original work. Now, a few years later, he took his work even further and dreamed up something that he called the ultimate display. It basically would turn the world into Alice's world through the looking glass. So wherever you looked in the world, the display would be there. It's like, well, how would we do this? Well, maybe we could invent a display that could track your head. Maybe we could do that, and then the display would be able to keep up with wherever you were looking and basically put the display wherever you were looking. So in 1965, he does this paper. He then goes off, and for 3 years, he works on making it really, and he invents what is now the first head-mounted display. Now, this is synthesizing a couple of things. So this is using tracking of the head. It is also creating an image that's being seen in real time, overlaid onto the real world. Because this is not something where you're just seeing a synthetic world. He's using silvered mirrors and cathode ray tubes and all sorts of old technologies to be able to overlay objects via the computer onto the real world. Now, in order for him to do that, he also had to invent real-time three-dimensional computer graphics. So yes, Ivan Sullivan invented interactive computing, he invented what we think of as virtual reality and augmented reality, and he also invented real-time three-dimensional computer graphics. So pretty much everything we do on a computer these days, with the exception of hyperlinking, well, all of that comes from Ivan Sullivan. All right. This has given us a very specific idea of what virtual reality and augmented reality look like, that it's something that goes over your eyes, and that wherever you turn, because your head is being tracked and your position is being tracked, you see the world through that display. In other words, the display becomes the world. Rather than a display that you see on a desk over there or on your palm, the display is the entire world. I'm telling you, that's not what augmented reality is at all. Augmented reality has nothing to do with technology. Augmented reality is a human activity that has two fundamental features. And you're going to see a lot of products from a lot of companies. This is a recent introduction from Snap, their augmented reality spectacles, that are going to be saying this is what augmented reality is. Augmented reality is not a specific technology. Augmented reality is a specific activity. And that activity is being able to take data and bind it to a specific place. And then to go back to that data and to render it so that you can see that data has been put into that space. Now, any technology that you choose to use to do that is absolutely fine. And because this is data, you do need some technological artifice to do this. But that technology doesn't rely on silicon. It doesn't rely on internet. It doesn't need transistors, because we have been augmenting reality for as long as we have been verifiably human. You know, those are the cave paintings in Lascaux, but you can go over to the Kimberley and see annotations in space that are verifiably 60,000 years old. So annotating space with data is an inherent human activity. And yes, it has changed the form over time, but the basic activity of recording something about space in that space, placing data into space, yeah, that hasn't really changed. And yes, we might stick a plaque on a building these days to provide some context about why that building was built and who built it. And aren't we great for putting up a plaque commemorating the people who built this building when they built it? But all of this is just augmenting reality. It's adding metadata, so data that would not be intrinsically visible to a space, by adding data to that space. So when you hear about augmented reality and people immediately think about spectacles that people will be wearing, no, that is one affordance for augmented reality. It is a technological apparatus that supports augmented reality, but it is not at essence what augmented reality is. All right, so now that we know that we can augment reality, that we can place data into space and add that metadata to reality, that actually makes reality contested. And I want to give you a little clip that will introduce why this is going to be so problematic.
Let's talk about art. Now, with augmented reality, you're going to be able to create and discover all kinds of new art around your city. So, this is a piece at Facebook headquarters. And, without augmented reality, this actually just looks like a blank wall. But when you are in augmented reality, you get this beautiful piece of art that's not just a painting on the wall, but it fills up the whole space. And it's 3D, and not only that, it's something that would be impossible to build or make in reality, because you have this infinite waterfall of paint coming down, and it's really quite something to look at. Now, one thing that's kind of a funny side effect of this is that now we're on Facebook, we notice that there are just people gathering around looking at blank walls. So, this is going to be a thing in the future, right? I mean, it's just people just kind of sitting around and staring at blank walls. So we actually put a physical plaque on this wall to commemorate that we think this is going to be one of the first pieces of augmented reality street art in the world. But there's a lot more like this coming.
So in 2017, before Cambridge Analytica, before all of the scandals, before the recent whistleblower on 60 Minutes, which happened yesterday in America, we all had a very, I suppose, Pollyanna-ish view of Facebook and its desire to connect the world. And when I saw this, my mind immediately went to all of the ways that sharing systems can be used to harass people, to hurt people, to single people out, to target people. And when you have a technology that allows you to arbitrarily write anything, anywhere, on anything, you have to have a very interesting discussion about when and where it is appropriate to write. For example, would the people who run the Grand Synagogue on Elizabeth Street in Sydney want to be able to let any passerby write whatever they wanted onto that building? And this is a fundamental question that we need to ask. What are the rights of that building and that building's proprietors and the people who use that building to have some say about what gets written in augmented reality about that space? How does what gets written about that space get shared? Who shares it? Why do they share it? All of this comes under something that I call the right to write. And Facebook is effectively asserting that they have a right to write whatever they want, wherever they want in the world. And they're not the only ones doing it. There are multiple projects from Google and Apple and Microsoft that all assert effectively the same thing, that because augmented reality is effectively invisible until some technological affordance makes it visible, there's no danger, there's no problem, there's no insult. But we know, and I'll point back to the opening example of the riot in Rhodes. We know that writing on space changes the behavior of the people in that space, and therefore the right to write is the right to change people's behavior with respect to a space. And so this is something that we need to consider very carefully. One thing that we also know is that Niantic is trying very hard to prevent any lawsuits from being settled against them in courts of law around the right to write. There was a group in Wisconsin and another one in California that got Niantic to take them out of the database because they were having these crowd events happening at Pokestops all around. And so Niantic's been settling these out of court because it doesn't want legal precedent set. But I guarantee you that by the end of this decade, there will be a body of legal precedents about when and where people can write things in augmented reality. All right. That's the external. Let's go toward the internal. Augmented reality has to have an awareness of space because it's revealing metadata in space, or it's allowing you to place metadata in space. Right now, we do that if you're using, for instance, a smartphone or even a pair of augmented reality spectacles, as you might get from Microsoft if you have a Microsoft HoloLens or something of that ilk. Those devices have to be very aware of the spaces they're in. If you're using Pokemon Go, it is using the GPS on that device plus the camera on that device to situate you wherever you happen to be so that it can situate a Pokemon there or a Pokestop or another player so that you can play with them. So augmented reality requires this very detailed notification of all the aspects of where you are and what you're doing. And that means that augmented reality definitionally is a technology of networked surveillance. And this becomes very clear when you take a look at what's called Project ARIA. This is a test platform for Facebook's forthcoming augmented reality devices. And I'll just play a clip from the introductory video that was revealed last year.
Project ARIA supports a variety of sensors that gather the sort of data that AR glasses will need to capture. These include a front-facing RGB camera, two side-facing monochrome cameras, and dual IMUs, which each contain an accelerometer and a gyroscope. This combination of sensors allows us to both observe the environment and track the position of the glasses, the wearer's hands, and objects within the scene. In this example, we can see the trajectory of the device being calculated from both the camera and the IMUs as the glasses wearer interacts in an apartment setting.
So it's really likely that by the end of this decade, with the release of commercial augmented reality spectacles from Facebook and possibly Google and Microsoft and Apple, that we're going to have hundreds of millions of these devices in play. It will be similar to smartphones. It's believed that this is the technology that will make the smartphone obsolete, because rather than having to look into our smartphone, the data will be constantly around us in the augmented reality environment. It means that every one of these devices will be analyzing and reporting its location and its activities at all times to the cloud computing provider, whether that is Facebook or Apple or whoever, who will be generating the data that will be sent back down to augment that individual's reality. This creates what I call the omnidirectional panopticon. Now, the panopticon is a term from Jeremy Bentham from the 1830s. And it talks about a prison in which there is a central guard observing cells that are arranged around them in a circle so that every prisoner is always under the expectation that they are being observed, and therefore they self-edit the behaviors appropriately. And you can already see how Facebook uses tracking and cookies to be able to track its users even when they're not on Facebook. Apple just put some things into iOS that is designed to slow that down as much as possible, probably in preparation for their own advertising platform. Mind you, they're not doing this out of the goodness of their hearts. But what they're doing when they're doing this is they're creating tracking systems so that they can profile you and give you exactly the stimulus you need at exactly the moment you need it, so that you can stay engaged with their advertisers on their platform. So these devices provide an entirely new level, a much richer data stream, and not just a little bit richer. We're talking orders of magnitude more richness. And that orders of magnitude more richness isn't just facing outside at the world, it is facing inside at the person who's wearing the lenses, because all of these systems feature what is known as gaze detection. That is, they use cameras faced inward toward the eye to be able to track the position of the pupil and therefore calculate the direction of the gaze. Now, this is done theoretically to help improve the rendering of the system, because you want to render in highest fidelity the things that are in the center of your view, what they call the foveal center. But in fact, what this does is it provides an extremely rich channel of tracking data, because you will look at things if they catch your attention, if you are interested in them. And this brings up a fundamental issue of privacy, because the gaze reveals things about us that our mind would try to hide. And if this is a basic element of all of these systems, then we will be giving over very specific and very private data about ourselves at all times. So we need to think very carefully about the data that gets used in augmented reality systems. Now, as these systems come out over the next couple of years, and they're already hesitatingly reaching market, but certainly by 2025, 2026, 2027, we will have mainstream versions of these that will cost as much as a high-end smartphone. They will start out as a very high-end toy and then will filter down more and more to the market. It's a good time for us to start to ask some questions, which is, where does all this data go? Does the data stay on the device, or does it go up to the cloud? If it's going up to the cloud, what's going up to the cloud? How much of it is going up to the cloud? How often is it going up to the cloud? How much of my personal activity is being captured and then uploaded, or just being saved? And then, How is the data being used? We know that Facebook's apps all continuously profile all of the users who use them in order to be able to use that data to be able to prime the feeds to keep those users engaged. And of course, the big whistleblower report that came out last night was that Facebook had learned that negative engagement, in other words, making people angry, was keeping them more engaged than positive engagement. And so Facebook tilted all of its algorithms in 2017 and 2018 toward negative engagement, which has increased anger and violence in the civilization as a result. So you have to ask yourself how that data is being used and what it's going to be used for. All right. Then, who owns that data? If this is a device that is sitting on your head, and it's designed to help you make your way through the world, and we'll come to the uses of AR momentarily, there's a big question about who owns that data. I mean, I wear an Apple Watch. You just saw me look down to fiddle with it because it was going off in the middle of this session. I don't really own the data streams that are coming off this watch. This watch has a continuous monitoring of my activity levels, of my heart rate, even certain features of my heartbeat if I want it to. That data is not really visible to me. It's not really being stored anywhere that I can use it or in a form that I can just hand it over to my doctor or to my exercise physiologist or whoever it might be. And so we have these systems that are designed to collect data but not designed to be able to share that data with the people who it is being collected from. And this is probably going to be an area where we're going to need actually strong regulation to make sure that the data is always owned by the person that it's being collected from, because if you don't do that, then that data gets liberated and used for other purposes. All right, so these are 3 questions you need to ask whenever you're encountering any technology that purports to be augmented reality. Okay, I have given you all of the negatives. I have hopefully given you, I think, a very bracing view of what augmented reality is and how it can be used. But why would you bother to use it at all if it is so problematic? Well, let's be clear here. Although it is problematic, it is also a very powerful technology. And it's powerful because there is another aspect to data collection which has revealed itself in this world. So this is the engine block, such as it is, of a 2020 Mercedes SEL. So top of the line Mercedes, probably what, about $130,000, $140,000 car. And if you open up the bonnet to take a look inside, all you see is a big plastic cover. Yes, you get to see where you can add some fluid if you want to be able to put some fluid into the radiator and the cooling system, or some fluid into the windshield wipers, and I think possibly some brake fluid. Those are the only quote-unquote user serviceable components in here. Everything else is covered in a big plastic cover because you're not supposed to touch any of that. It's not meant for you to touch any of that. In fact, what you do is when you need to service it, you take it down to the registered authorized Mercedes dealership. They plug it into a data port, and then the car's systems synchronize with the machine that it's plugged into and dump all of their data for analysis into the Mercedes system so that you can figure out what's going on with the car. And you think, well, that's okay, isn't it? Well, what happens if your car dies in the middle of nowhere? What do you do? How do you fix it? How do you even start to be able to think about fixing it? Now, this is going to be a big problem with petrol engines. It's going to be a weirder problem as we transition to electric vehicles, because electric vehicles are fundamentally far simpler. They're about 2 orders of magnitude less complex than a Mercedes petrol vehicle is, because electrical vehicles they're far simpler in their design and operation. And so you'd really want to be able to have some level of deep transparency around this so that you can actually fix it, at least temporarily, when it quits on you. But there's no way to do this in this design. And so Augmented reality allows you to bring the metadata of the engine's functionality to you where you are, in situ, in place. You can look down onto the engine and understand it. It will be revealed in its data dimension because every element of this machine has data associated with it. And certainly Mercedes tracks all of that data. It's part of their design and then engineering and then manufacturing and then maintenance processes. None of that is revealed to the owner, even though the owner theoretically owns the vehicle. So the question here is, why are they obscuring that data? Why is that data not offered to the owner on an as-needed basis to be able to help the owner make the most of their vehicle? Because that obscurity, the hiding of that data, offers control. In this case, what it means is it's regular revenues around maintenance of the vehicle. They really are not worried about people messing up the vehicle because that would be voiding the warranty. What they do is they want to be able to have control over that vehicle. And we see this happening more and more as devices become more and more electronic. People use smartphones. If your smartphone breaks, you have no way to be able to repair it because there are really no usable repairable parts inside. It's true for also PCs often. It's true for so many of our electronic devices. And as a car becomes more and more an electronic device, even as it's an electromechanical device, it starts to adopt some of those features. It's also happening in farm equipment. If you buy modern high-end farm equipment from John Deere, you basically sign a license agreement that says you can't play with the equipment and they can do whatever they want with it. You are not really buying the equipment, you're just licensing it from them. So there's this basic idea that obscurity grants the manufacturer control over the device. But augmented reality can in fact help amend that. It can bring the technology and the insight of the device to the user when the user wants it or needs it in order so that they can have some control over the device that notionally they do own. This is an interesting point when you take a look at an automobile. But I don't want to talk about it as an interesting point. I want to talk about it as a point of life and death. Because where we are right now is we are surrounded by systems that are consuming energy, and we don't have any way to be able to profile the use of that energy, or where that energy is being generated, that it's being used, or any of the energy that was being used to create the devices that we are using. So we cannot regulate our energy flows, which means we cannot regulate our emission flows, which means we cannot lower our carbon emissions, which means we will heat ourselves to death in very short order. Now, in order for us to avoid doing that, we need as much transparency as possible, not just in the supply chains of how things get made, but also in how they're being used and how we can optimize their operation at all times so that they use the least energy possible. And this is something that we haven't thought about when we think about the design of our devices, but it's something going forward that we absolutely will need to be thinking about. And so we need to be able to take a look at a device with a bit of depth, or we need to be able to take a look at some lamb that's sitting on a shelf in the butcher and understand what the carbon impacts of that particular lamb from that particular grower were, so that we can incorporate that into our own management of our own carbon emissions. Now, I know all of this sounds like a lot of work. There's going to be apps to handle that, but apps will need to be fed with those streams of data. And so this idea of transparency around all aspects of human productivity, this is one of the paths forward into a sustainable economy. And if we don't get that transparency, sustainability becomes nearly impossible to manage because we can't have any external reference that allows us to understand whether we are tacking toward or away from sustainability. All right, what I want to do is I want to move toward a close by showing you a 6-minute video of a piece that I saw back in 1995 that changed my life. Now, this piece is pertinent because it is the subject of a film that is being released on Netflix on Thursday. Have a watch.
T-Vision is a telecommunication research project. It provides a virtual globe as a multimedia interface to visualize any kind of data related to a geographical region. The virtual globe is modeled from high-resolution spatial data and textured with high-resolution satellite images. A T-Vision database, a real-time rendering system, and a specific telecommunication concept has been developed to handle this infinite amount of data. We are just approaching Japan, flying over Tokyo Bay, and now heading towards Mount Fujiyama. T-Vision's specific concept of seamless links between different levels of detail allows the continuous zooming from a global view down to recognizable features of only a few centimeters in size. To enable this, we developed a renderer which asynchronously loads levels of detail into the memory, dependent on how close our view of the Earth is. By switching the surface off, we can observe this process more easily. As the distance between us and the Earth increases, the high-resolution data is removed from the memory and is replaced with new data for the wider field of view. Out of these different levels of altitude data, we compute the tectonic surface of the Earth and then project the corresponding satellite images onto it. An asynchronous and anticipatory loading strategy always guarantees us 30 frames per second. A combination of two interfaces is used to navigate around this virtual globe and interact with it. A space mouse is used to control the user's position and angle of view in relation to the Earth. And in order to move the Earth itself, a so-called Earth tracker was developed. On the virtual globe, any kind of geographically related data can be incorporated, whether static or dynamic. Ecological, sociological, and political data could be visualized to provide decision makers with a comprehensive interface for assessment, risk evaluation, and planning in a wide variety of fields. For example, the latest satellite cloud images from weather forecasting providers can be integrated into the system over an ATM link. The user thereby has full control over which information to view, at what time, and at which location. We are now approaching the west coast of the US. Here we request weather data and get an immediate ATM connection to a weather server which provides the current temperature data for this region. Any kind of 2D visual information can be presented on these so-called information actors, which are displaying temperatures here. Alongside the telecommunicative integration of these various layers of information, the T-Vision project is based on the concept of a transparent and worldwide broadband network topography and surface data bank. Because of the impossibility of locally storing and constantly updating all the high-resolution data necessary for such visualization applications, the system automatically establishes an ATM connection to the server which provides the most up-to-date and highest resolution data required for the current field of view. For example, we have approached Berlin, but the data necessary for visualizing the city isn't available at our location. The computer makes a connection to a Berlin databank, accesses the necessary information, and integrates it into the running system. As another information layer, the system also allows the integration of CAD models. Here, the area around the Memorial Church and the Kurfürstendamm, where the ART+COM offices are located. We can also enter our building. Besides allowing us to move in virtual space, the system allows us to travel through time and get access to historical information. Here we are at Potsdamer Platz, before the Second World War Europe's busiest traffic junction, and during the Cold War, a no-man's land between East and West. We can take a trip through time and see how the area has changed over the years. As well as historical film clips, the system also allows access to live cameras as windows onto reality. During the presentation in Kyoto, the system offered a live video signal from a remote-controlled camera installed in the ART+COM office. Remotely controlled by the user in Kyoto, the camera could show the church clock with exactly 8 hours time zone difference, nearly real time, if we take the 250 milliseconds transmission delay into account. In the future, we will develop T-Vision further as a multi-purpose interface, providing users with any kind of information and telecommunicative services which can be meaningfully organized and visualized on the virtual globe. Our goal is now to motivate people around the world to be part of this distributed system, people who will provide it with their own local information and services.
So that system is 26 years old. And if you're looking at it going like, oh, that looks a lot like Google Earth. I wonder what happened. Well, that's the plot of the billion-dollar code, because it turns out that maybe Google, well, we don't want to say stole the code, but we maybe want to say got the key engineers. And then there was a large lawsuit that worked its way through the German courts on that topic. But the point I want to make here is that 26 years ago, the goals for T-Vision were far more ambitious than anything that you see on Google Earth today. Google Earth will basically just show you some buildings and some roads. Big deal. The world is far more complicated than that. The world is far more rich than that in data. And guess what? Google has all of that data. But they choose not to show it. They do choose to use it. They keep it internally, and yet they don't release tools that actually give us that data that they've gathered from the real world. And so when you look at these systems, 26 years ago, there was a clearer vision of what actually would be useful as a tool than the tool that we have today, which is basically just a tool that's used to market. So as we enter the next level now of augmenting reality, of using the tools to help make sense of the world, consider the full depth of the experience that you want to be able to experience or to present, because many of you will be designing these systems, and you'll need to think carefully about the data that you need to collect and the data that you need to represent, why and how you're doing this. Thank you very much.